In this lecture, I'll discuss some of the consequences of the two postulates of special relativity, namely in this lecture, the universal speed limit. Special relativity states that speed is finite, meaning that there must be a speed limit. This limit is 3 times 10 to the 8th meters per second, which, as you might remember from the previous lecture, is the speed of light. This means that no object in the universe can travel faster than the speed of light. The theory of special relativity states that this speed limit applies to physical objects, such as a baseball, as well as field lines. Field lines are the imaginary lines physicists draw to develop the notion of forces through space. What does it mean for a field line to have a speed limit? This implies that forces can only travel slower than the speed of light, which means that it actually takes time for a gravitational field to permeate space. This is a very interesting notion. 3 times 10 to the 8th meters per second is mind-bogglingly fast. It's fast enough to travel around the circumference of the Earth almost 6.5 times every second. That's pretty incredible. Sounds like the universal speed limit won't be slowing us down anytime soon. A related notion is the idea of relativistic mass. This is another consequence of the two postulates of the theory of special relativity. Relativistic mass basically entails that as you approach the speed of light, it becomes more and more challenging to accelerate. That is, more and more force is required. This means that if you're increasing in speed, say you have velocity or time, you're accelerating when you approach the speed of light, you won't just stop accelerating abruptly when you hit the universal speed limit. Instead, your velocity will increase at smaller and smaller increments, and you will never actually reach the universal speed limit because your relativistic mass at this point would be infinite. This means that we can never travel at the speed of light. This also means that our graph will taper off as we approach the speed of light. The speed of light is generally denoted as c, as I'll write on this graph. In the next lecture, I'll cover time dilation and length contraction, which are two other interesting consequences of the theory of special relativity.